Ranging from 5 to 70 km in depth, the crust is the thinnest and outermost layer of the earth. We live on the crust, which is divided into two types, continental and oceanic. The continental crust is thick and is made up of felsic rocks containing lighter elements such as silicon, oxygen, aluminium, sodium and potassium. These rocks are light in color, for example granite. The oceanic crust is thinner but denser than continental crust. It consists of mafic rocks, which are denser than felsic rocks and is made up of magnesium and iron. Most mafic rocks are dark in color, for example basalt rock. Layer that combines the uppermost mantle and crust is called the lithosphere. The lithosphere consists of tectonic plates that float on the upper mantle. The outermost layer of the earth that is composed of soil is called the pedosphere. It acts as a mediator between the lithosphere, atmosphere, hydrosphere and biosphere. The lithosphere layer can extend up to 70 to 100 km in depth. The region between the lithosphere and the uppermost layer of the mantle is called the asthenosphere. It is highly viscous, ductile and hotter than the lithosphere. It extends from 100 km to 700 km below the Earth's surface and acts as a lubricant that allows the lithosphere to float smoothly. The mantle is the largest layer, comprising 84% of the total volume of the Earth. It consists of silicate rocks that settle in between the crust and the outer core. It has a thickness of about 2900 km. The mantle is divided into upper and lower mantle, separated by a transition zone. As we move deep into the mantle, the pressure increases and the lower mantle flows more slowly than the upper mantle. The viscosity is so high that it ranges from 10 to the power 21 to 10 to the power 24 Pascal second. For comparison, viscosity of water is 0.00089 Pascal second. The Earth's outer core lies beneath the mantle and consists of liquid iron. The temperature of the outer core ranges from about 4030 to 5730 degrees Celsius. It can melt iron, but the pressure is not strong enough to convert it into a solid form. It is around 2200 km thick and goes as deep as 3400 km into the earth. It consists of 80% iron, nickel and a trace amount of lighter elements. The fluid viscosity is low and can spin faster than the earth itself. When heat escapes from the outer core, it gives rise to the convection currents. The electric current produced due to the motion of convection currents of molten iron generates the Earth's magnetic field. In 1936, Danish seismologist Inge Lehmann discovered that the Earth has a solid inner core beneath the molten outer core. She came to the conclusion by detecting the seismic waves which got reflected by the water of the inner core. The inner core has a radius of about 1221 km and pressure ranges from 330 to 360 gigapascal. Its temperature is between 5100 degrees Celsius to 5400 degrees Celsius, which is almost equivalent to the sun's surface temperature. Due to extreme pressure, iron melting point increases and manages to remain solid. The inner core is believed to be composed of an iron-nickel alloy. I think that's enough for today. I hope you guys have a wonderful day. I will see you in the next video. Thanks for watching.